Alrighty. This is the only other section we're going to be doing in Chapter 5. We're going to do this section, as I said, in the two sections that were combined into one, and we're just going to review that material and finish the semester up with that. So let's go ahead and jump into 5.1. 5.1 is going to be on mid-segments of triangles. Okay, so let's start out with the definition. A mid-segment of a triangle is a segment with endpoints at the midpoints of two sides. Okay. When we look at this, it says start thinking. Draw the midsegment containing AB and AC. If here is AB, the midpoint is roughly there. One tick, meaning that's the midpoint. Then we find out where the midpoint is of AC. If I measured it in millimeters and divided by 2, this is where the location would be. Now, if I draw the midsegment, there's your midsegment. Try to figure out how does the midsegment relate to that third side. There's two things. The triangle midsegment theorem says if a segment joins the midpoint of two sides of a triangle, then it will be, what is one thing you notice between that and this? Looks like they're parallel. It's going to be parallel and 1/2 the length of the third side. What do I mean by the third side? Well, this side over here had the midpoint, this side over here had the midpoint, this is the third side, the one that we didn't talk about. If I went over and I drew a different triangle and I said, here's the midpoint of that one, here's the midpoint of this one, and I connect those, you can see this one is now going to be parallel to that one. And if you measured this length and you measured that length, this one would be half the length of that one. Okay. So that's basically the most important thing with 5.1. It's just about a mid-segment, and mid-segments are going to be parallel and half the length. And I'll be able to create problems where you have to use both of those aspects. So it says triangle XYZ, XYZ. XYZ has A as a midpoint of XY. A is the midpoint of XY. B is the midpoint of YZ. B is the midpoint of YZ. And C is the midpoint of XZ. C is the midpoint of XZ. So basically what you have is you have a midsegment. Here's another midsegment, and here's another midsegment. Okay. What are all three pairs of parallel segments? Well, midsegment AC is going to be parallel to what side? AC must be parallel to YZ. What about AB? Midsegment AB is going to be parallel to which side? XZ. And then lastly, BC must be parallel to what side? BC is going to be parallel to this side over here, YX. And those are the ones that we would be parallel. Midsegment is going to be parallel to that third side. If we go ahead and look at this, it says triangle NOM. Make a triangle. NOM has U as a midpoint of NO. U as a midpoint of NO. Okay, and V as a midpoint of MO. V as a midpoint of MO. So that's that midsegment. if angle N is 65 degrees and angle O is 30 degrees, then what is OUV? OUV. It says, what is this? Question mark. So we start thinking, is this going to have to do with the fact that they are parallel or the fact that they are going to be half the length? Well, it's got to be the parallel aspect. If we looked at let me try. If we look at this side being parallel to that one, this is kind of like a transversal. Two things, and that's the transversal. They said this was 65 degrees, and they wanted to know what that angle was. What type of angles are those? Looks like it's corresponding angles, and those are congruent, which means that OUV must also be 65 degrees. It then wants to know what OVU would be. OVU. What is this one? How the heck am I going to do that? Well, I am going to do it by looking at this triangle and saying we knew that this one was 30 degrees. We just found out that this one was 65, and we want to know what that is. What is the thing in the geometry toolbox which is going to tell us the leftover angle inside of the triangle? Oh, that's triangle angle sum theorem. So if we did 180 degrees minus 65 minus 30 would give us, so it's basically 180 minus 95, and that would give us 85 degrees left over. So it should be 85 degrees. You might say, but how come this is 65 and it's an obtuse angle? It's just how I drew it. I messed up when I drew it because I didn't know what they were going to want. So this would be an example of how I could throw in an application to things being parallel. If we know things are parallel, then I can use alternate interior angles theorem, corresponding angles theorem, and I can use alternate exterior angles theorem. I can use all of those things. When it comes to things being parallel, I can also know from Algebra 1 that parallel lines have the same slope. Somehow I can put that into the problem. You got to think about all the things we can do with parallel lines. Let's go ahead and move on. On this one right here, it tells us that this is 30, 30, 50, and 40, and it wants us basically to figure out everything else. If this mid-segment is 30, what's this total length? 60. If that's 40, then what's this? 20. And if this is 50, what's half of 50? 25. There you go. So this problem right here would have to do with the fact that the midsegment is half the length of the third side. Okay, let's move on. If you got a problem like this and it wanted to know what is the value of x, you have to ask yourself, is this going to be using the fact that they are parallel or that it's half the length? I think that it's going to be the half the length. So if we wanted to do this and I wanted to show all steps, I could say mid segment equals 1/2 the length of the third side. The mid segment is 5x minus 2, and that must be 1/2 the length of that third side. The third side is 9x plus 10. So you have a few choices, 2 choices to be exact, of how you would do this. If both the numbers inside here were divisible by 2 easily, then you could always just distribute the 1/2. I don't want to deal with 4.5 though, and 9 is not divisible by 2 nicely. Another way you could do this is if you multiply this side by 2 over 1, that cancels out, and then you'd multiply that by 2. So I decided to double that and set equal to this. So double 5x minus 2. If I double that, don't forget to distribute, you end up with 10x minus 4, and that equals 9x plus 10. We solve that. Minus 9x is just x. Plus 4 is 14. So once again, you can double this one and set equal to that, or you could half that one and set equal to this. Both of them mean the same thing. So I can double this one and set equal to that one, or I could have everything in here and set equal to that. I'm going to double this because that's much easier. Double that, and that gives you 4x. And that's going to equal the longer length, 3x plus 10. And when I solve this, minus 3x, you end up with x equals 10. Now make sure what you do makes sense. I have a lot of people every single year who try to double the long thing and set it equal to the short. That makes no sense. Double the shorter one, and that will equal the longer one. All right, let's keep on cranking. Now a real world example of how we would use this. Hang on. How would we use this? Well, let's say that a person was trying to measure across a lake. They didn't want to have to go over and get a string and row the boat across the lake. What they could do is make a triangle. They could then get this mid-segment. Let's see if I can do this. Get the font a different color. Is that red? No, it's not red. Give me 1 second. I'm trying to get it red. Okay. This would be very easy right here to measure because it's on land. And since this would be a mid-segment because it connects the two midpoints, then once you have measured that, you'd be able to figure out what this is. They say that the mid-segment is 46 feet. So what would this be? Do we have the short and that'll equal the long, or do we double the short and get it equal to the long? We would double the mid-segment and set it equal, or it's going to be the length of the long. So if the mid-segment was 46, we just have to multiply by 2 to get 92, and that would be the length across the lake, 92 feet. All right. Now here's something else I could always tell you. Let's do a little application. Here's the midpoint. Here's a midpoint. That is AB. This is CD. If I told you AB had the equation of y equals 5x plus 2, and I wanted to know what is the slope of this line over here, CD. Well, since you know midsegments are going to be parallel to the third side, then AB must be parallel to CD. Remember, parallel lines have the same slope. We learned that in Algebra 1. So here is the slope. That's the y-intercept. That doesn't help us. The slope of AB is 5, so what's the slope of CD? It would also be 5 because parallel lines have the same slope. We would be using the fact that midsegments are parallel, not that midsegments are half the length. All right, let's go ahead and take a look at this. Game and Fish Warden wants to create or measure the distance AB, just like the last problem across the lake. He finds the distance EB and EC and locates C and D, the midpoints, of EA and EB. What is the distance across the lake? Well, I think what I'm going to do, I know this problem could be done in different ways. I'm going to try to figure out what the mid-segment is, and then I'll be able to double it, and that would be the third side. So somehow I need to figure out if this is 1,000, if that whole length is 1,600, and this is the midpoint, then this must be 800, and I wanted to know what that is. Looks like they put a right angle marker. Does anybody know how to find the third side of a right triangle if you know the other two sides? Well, You ask Pythagoras, and Pythagoras tells you it is a squared plus b squared equals c squared. So 800 squared plus b squared equals c, which is the longest side of the hypotenuse, 1,000 squared. If you did this in your calculator, you would end up with 600. So the midsegment is 600. If the midsegment is 600, then what is going to be that third side? It is going to be 1,200 feet. All right, let's finish up this section with just a little reminder about proofs. Let's do a little practice with proofs. It says, notice that when all midsegments are drawn, 4 triangles are created. Visually, what do you notice about all the resulting triangles? Use your skills from last chapter to justify your conjecture. What looks to be true about this triangle, that triangle, this triangle, and this triangle? They all look to be congruent. They all look to be congruent. So let's try to justify that. Notice that going from D all the way to F is 2 single tick marks, meaning this is a length of 1 tick mark and this is a length of 1 tick mark. So the whole length is 2 tick marks. If this is a mid-segment, it's supposed to be half of that length, then what would its length be? This is 2 single tick marks. Therefore, this must be 1 single tick mark. If this length right here is 2 double ticks, and this is half of that, then what is its length? 1 double tick. If this is 2 triple ticks, this is half that length, what should it be? 1 triple tick. Now look at triangle 1, 2, 3, and 4. Why are all those triangles congruent? Is it SAS, SSS, ASA, AAS, or HL? Which one of these? Look at triangle 1 and 2 and compare them. Why would those 2 triangles be congruent? SSS is the answer. So that would be a way. Once again, we learned proofs, and we're not going to be doing way too many just flat out proofs for fun, but we're going to be using the logic that we learned in previous proofs to be able to prove things. For example, if you had a kite, this is a kite. By definition, a kite has these 2 being congruent and those 2. If you said, I wonder if this is congruent to that. Well, a justification is you can make a line down the middle. Oops. Make a line down the middle. Then you could say the reflexive property says that that is congruent to itself. The 2 triangles are congruent by SSS, so that's congruent to that by CPCTC. We'll be using the concept of proofs to justify things going forwards, but we're probably not going to be doing way too many just straight up proofs. Almost everybody in the last test proved to me that they understand proofs, which is cool. All right, just as a reminder of what we did in this section. This section was about midsegments. A midsegment, it connects the 2 midpoints. It is going to be half the length of the third side and parallel to the third side. I can make many different problems that have to do with it being half the length or being parallel. So just look out for those things. Thanks for watching.